webinar for you today as part of our Python Live series, focused on an introduction to practical MLOps. So I'm joined by the award-winning Andy McMahon, who's a machine learning engineering lead at NatWest. Andy has also authored a book called Machine Learning Engineering with Python, which, as a thank you for everyone joining the webinar, you'll all receive a 25% discount code. And Andy's also kindly arranged for a random giveaway of 3 ebooks, which will be arranged afterwards. So I'll hand across to Andy shortly. We're going to have a couple of small breaks after each section of the webinar. So for kind of Q&As, there's a Q&A tab at the bottom of the screen. So please feel free to drop any questions you've got in there, ask as many as you'd like, and we'll do what we can to get them answered for you. So Andy, thank you for joining and taking the time to join the Python Live series. So I will hand across to you and the floor is yours.
Thank you so much, Amber. Thanks for the kind introduction. Hi, everyone. Really excited to be here. Appreciate Amber and the team fixing this date by, first of all, a week due to a calendar snafu at my end, and then by another half an hour due to a technical issue. So we got here in the end. So as Amber said, what I'm going to talk about tonight is a practical introduction to MLOps, or kind of a bit more colloquially, how to actually get started with this stuff. MLOps is a term that's thrown around everywhere, sometimes seen as a bit of kind of black magic or hand waving. So tonight I'm really just going to try and outline what I see through my experience and working with teams across different industries in this area. What I see are the kind of basic building blocks, the basic ideas you should start with, and we'll go from there. 2 quick disclaimers. One, I don't know the answer to all the questions I'm sort of posing in this talk, and I'm just giving my best shot at how you should approach this stuff. So I don't think I'm the leading authority in this by any stretch of the imagination, but I do think I've got some ideas that you might benefit from hearing. The second one is everything I'm saying tonight is off my own back. I don't represent my employer tonight, except at the very end where I talk about some stuff that NatWest have done. So if I say anything really bad, it's me, it's not the bank. Okay, so let's crack on. So today, looks like I've got tons and tons of stuff to get through. These are all lots of little sections that we're going to get through as a bit of this introduction to MLOps. So first I'm going to set the scene a little bit, make sure we're all on the same page about some terminology, make sure we agree kind of what I'm using when I say MLOps, what I mean by that. I then go through a brief kind of crash course in some of the introductory topics, a lot of which I cover in the book Amber mentioned, but some of which are also just little add-ons. I'll intersperse that with little code snippets. We'll open up for Q&A and we'll hopefully have some fun just chewing over these topics. And then at the end, I'll talk about how you could take some of the basics I've outlined in this crash course and scale it up to the enterprise level. And that's the point where I talk about some of the work we've done with NatWest and AWS, which is now in the public domain. We're on the AWS machine learning blog, and we presented the AWS Summit, London and Berlin earlier in the year. So I'll talk about that at the end. So let's just crack on. We've got plenty to get through. So setting the scene. Why do we care about MLOps and what are we trying to do? So I'm going to start with this quote, which is one of my favorites. And this is by James Clear, who's the author of Atomic Habits. Got a weird feedback, Amber. I don't know if it's your mic on or something.
I'll put myself on mute.
No, sorry, no worries. So James Clear, who wrote the book Atomic Habits, which you all might have heard of, and he says, you do not rise to the level of your goals, you fall to the level of your systems. So what we kind of mean by this is that although your aspirations might be really high, fundamentally at the end of the day, it's the systems and processes you've built that will determine where you end up in your projects, in your team, in your organization. So for me, MLOps is really about bringing this type of thinking to your machine learning projects, your machine learning products and services. So how do we make the level of our systems as high as possible so that it's not too far away from the level of our goals? And that in a nutshell for me is what MLOps is about. And the reason that's so important and quite challenging in machine learning is that traditionally it's been very hard to get machine learning right. So you've all probably been introduced to or heard some of these opinions and articles and pieces through the years that basically tell us that 90% of all ML models, all ML projects fail to get into production. We're really good at developing, especially in industry, models that can solve problems in principle, but getting to that stage where we solve it in practice is actually very difficult. So again, another way of phrasing the MLOps problem really for me is how do we switch that around and make sure 90% of projects actually succeed? How do we make the success rate so high rather than the failure rate? And that's really what it's about. So again, tonight, we're just going to talk a little bit about some of the ways I think you can start getting on the road towards that 90% success rate. And again, it's not the full story. You'll have to learn a lot of it yourself. You'll have nuances in your particular industry or organization. But I think there's a lot that we can share in this sort of forum that will help each other on this journey. And it's not just me saying this, it's big companies, organizations, consultants like Deloitte and others. There's a lot of literature out there that supports this idea that this is super important, especially as we enter this new phase of AI where we're so used to the 90% failure rate that we have to really turn the tide and change how we approach things. So in these two reports from Deloitte last year, their tech trends and their state of AI reports, they really focused in on this and just quoted some statistics around how organizations that enforce MLOps processes or really think strongly about their change management processes, especially when it comes to machine learning, are just far more likely to achieve their goals. They're far more likely to weather any risks that might manifest in the future, and they're far more likely to move a lot faster and create value at a much faster timescale and a much larger scale. So it's not just kind of, this is not a niche area. This is, for me, where data science to machine learning is now. We now need to get to that 90% success rate, essentially. And just one bit of nomenclature before we carry on. My book, as Amber mentioned, is called Machine Learning Engineering with Python, but then in the subtitle, it mentions MLOps. So already there's a bit of a confusion that could potentially arise. And in fact, today on LinkedIn, I was commenting on someone's post. Someone asked the question, what's the difference between ML engineering and MLOps? So I'm just going to give my version of the answer. But again, I don't think I'm necessarily the authority on this. So for me, machine learning engineering is the equivalent of software engineering, but for machine learning. So it's about getting your data science models into production by applying enough software engineering practices and principles. So it's really that building aspect, building, push to deploy. MLOps is much wider and encompasses, subsumes ML engineering, but it's really about the end-to-end lifecycle management of your models, your solutions, the systems that contain machine learning within them. So it's not just about how do you get a model into production, it's about how do you keep getting models into production, how do you do it faster in a more automated way, how do you monitor the models that are in production to make sure that they're doing what you need them to be doing to generate value, and how do you minimize risk through that and surrounding processes, on top of all the things you should do as a standard software practice. So that to me is the slight difference between the two. Roughly, you can use them interchangeably, but MLOps to me is far more encompassing. It's got a lot more contained within it. And then finally, one other flavor of this that I like to think about that maybe helps tell this difference and split it out is I trained as a physicist. Some of you might have trained as mathematicians. Apologies if you're neither of those, but if you are, you'll have heard of this idea of proof by induction. And fundamentally, in a mathematical proof by induction, you need to prove the first case, and then you prove that if the first case is true, the next case is true, and then basically you prove all cases. So for me, getting your first model into production is really like proving that first case. Can you do this in principle? That's ML engineering, or at least how you initially learn it. Can you get that first model into your production environment, serving requests and generating value? And then MLOps is really about given a model in production or models, can you successfully and robustly and scalably put the next one into production or replace that current model in production? And that automatically generates lots of new questions, right? How are you storing the models? How are you managing the models? How are you making the decision to change the model? How are you going to monitor the model to know when you need to make that decision again, etc. So to me, if you take a typical project, and in the book I outline it in these 4 stages, any machine learning project really, for me, falls into a discovery phase where you understand the business problem, a play phase where you develop prototypes, a develop phase where you build the solution, and then a deploy phase where you get it out there into production. ML engineering is your first run through of that, and MLOps is really how do you keep running through that as a holistic set of practices. Okay, so hopefully that means we're on the same page, or at least you understand how I will be interpreting these things and speaking about them tonight. And one final point on MLOps in general is that MLOps to me is not about tools. So we have a real danger now, because it is an exciting time in this field and it's an exciting area, and it is where the forefront is, especially in industry, that we start thinking about tools as the main thing. And then the problem with that is there are just so many tools out there that purport to do some part of the MLOps problem, or even all of it. These are just some of them, right? But there are tons out there. Maybe you're using some of these, or a plethora of others. And this can really lead to analysis paralysis, in my view. You can start thinking, what is the perfect tool I need to choose? And you can spend time endlessly playing and trying to understand which tool you should go with. Do I go open source? Do I go enterprise? Do I go for this kind of pipeline tool or that pipelining tool? What do I do for model management, etc.? What I'm going to focus on tonight is hopefully things that are a bit more abstract from that, and such that when you think about the basics of your Python code, the processes you should make in your solutions, and how that sticks together, you can swap in and out these products for the different stages you have to do. What's really important for me is that MLOps is about process. It's not necessarily about the tool. It's about the processes you're doing. And we'll cover a lot of that tonight. Good. So that's the setting the scene. I'm now going to plow on with the crash course, and then, as Amber said, I'll take some breaks through it, because there'll be a bit of a whirlwind, so we'll maybe need a breather. I'll definitely need a breather, and then I'll answer questions sort of as we go. So MLOps 101, what's the first thing we should worry about? So I think the first thing you should worry about is, what is the goal? And the goal is to get things into production again and again, like I said earlier. So that automatically starts us asking the question, what does production mean, and how is it different from any other environment? And that then gives us this idea of a route to live, which is a core component of classic software engineering and developing software solutions. But if you come at this from a more data science background, that might be a bit newer to you, right? So the idea is that you have separated air-gapped environments, software environments, where you can do the different stages of your project, and they fulfill different purposes. So your development environment, your dev environment, is typically where you do the prototyping, the playing, the initial building. Pre-production or test environments is where you test that they work as you would expect before you push into production, which is where you're serving live results, you're running and interacting with business systems, you're maybe feeding back results directly to customers. So really that environment staging is what a route to live really is, and that's how you get up to that production stage. So that starts raising some other interesting questions, right? So as Python developers, I'm going to write Python in each of these environments. And as a machine learning developer, you're probably going to use Python, at least in some sense, and it's one of the best tools and ecosystems out there for it. So how are we going to manage in these different environments? We're going to have to start thinking about things like package management, Python virtual environments. We're going to think about containerization, how that allows us to be platform and environment independent. So you have to think about all these things before we've even touched any data, before we've even touched any modeling, right? I've not imported scikit-learn yet, or import pandas, or import numpy. I'm just thinking about how am I going to set myself up to do those things in a way that allows me to go up to production. And that to me is the first part of MLOps. You then have to think about some other things, like I'm not just going to run my models, I'm going to store a lot of data, I'm then going to surface the results. How am I doing that? How am I sticking that all together? And what choices am I going to make to do that? And in the machine learning world, it's very difficult because there are so many choices for each of these, and things become a bit more complex than maybe traditional software development. So if I take an example, like in storage, you're not just storing the data that you need to run the application on, you're often storing the model artifacts that you create. You'll be storing metadata about those models and the data used to train them. You'll maybe be storing training results and experiment results. You'll be storing the results of actual inference runs, etc., etc. So there's just so much data you have to store of different types and in different places. We'll talk about some of that later. On the compute side, machine learning models are a compute-intensive piece of software, typically, especially for training. So you have to start making decisions about the hardware you need and the processing type you need. So do you need everything to be distributed at very large scales, in which case you maybe go with Spark? Do I actually need things to be very fast and optimized for really large matrix operations, in which case I go GPU? Is it actually quite lightweight compute I'm doing, and it's small data volumes, in which case CPU is maybe the most cost optimal version to do. But again, lots of choices. And then finally, in surfacing and serving, how am I getting the results out into the world? Am I exposing an API? Am I just doing batch processing and sending that data to somewhere on my data lake? Am I publishing to a Kafka topic that someone or some other system is subscribing to, etc. So it's, even before we've touched any code, there's lots of choices to make. And these choices, as you can see, they're tool independent. There are lots of tools you can swap in and out for these pieces, but the key thing is just getting these elements in place and understanding their importance. And then the final bit that really is very different, I think, in my opinion, from traditional software is the monitoring piece. So a machine learning model is different from traditional software in that it needs fed and watered almost. It needs looked after. You need to check in on it, right, and make sure that it's operating within the parameters and risk profile you're happy with. And you do that through different types of monitoring than maybe what we typically do in software. So rather than being interested in things like latency, CPU usage, and we might still be interested in those things, probably should be. We're now also interested in how are my precision rates with time, how is my accuracy rate, how is the data that I'm feeding into the model looking in terms of distributions, is that changing through time? So there's new types of monitoring we need to do as well, and that's the critical part of MLOps. Quickly run through the next section, then we'll stop for some questions. So MLOps 1 and 2 is the code can change dramatically. So we are used to maybe working a certain way for data scientists particularly, and then going into production software is a very different story. So I'm going to illustrate that with a little bit of an example here. So hopefully this video looks okay. I'll start with a Jupyter notebook, the classic tool of the data scientist. Here I've got a basic demand forecasting problem. I want to forecast the number of items in a typical store with time. And what I'm showing here is just typically how I would, when I was a proper data scientist, I used to do these things, right? So you import Facebook profit, you read in a CSV, you've got the flat file, you then just start exploring the data types, you're transferring things to date time, you're splitting things out, you're doing kind of that exploratory data analysis piece, that discover piece I mentioned earlier. And you're just fumbling around, trying to see what's happening. You maybe do the first bit of separating out the data you're interested in, you do some plots, you've got code here that you've commented out, you don't need anymore. I then start thinking a bit more about, okay, what is the actual ML problem I want to do? So here I've got a little train predict function that's going to wrap some basic profit functionality. And then later I'm going to apply that to some data. So what I do is I start thinking, right, here's a little bit of subset of data I'm going to separate out, how am I indexing that? I'm going to run, train the model, do a little bit of inference, and then do a plot. And what you can hopefully see from that is that I've still done what I set out to do. I set out to explore the data and see if I could solve the problem in principle. So there's nothing wrong with coding this way, right? You don't want to over-engineer too early in the project. But it should be clear to us that that's very different from something that I would trust to run 24/7, 365 and service requests for forecasts that would then make really important decisions for a business, right? There is a difference there. And that's fine, but it's just important to recognize that as part of this process. So you then start thinking what has to change in the code. So on the left-hand side is a little screenshot from that notebook, and this is discussed at length in the book, right? So just drilling in a bit, I've got a data frame called DF. We always call our pandas data frames DF. I've got time series splits going on. I've got a temporary variable called temp. I'm then iterating and doing for loops to then generate lots of different plots to see what's going on. Again, a lot of that stuff is not what I need for production. So I then make some decisions. Do I want to code my Python in an object-oriented fashion? Do I want to go functional programming? Either's fine, both mixed maybe can work as well. How do I start embodying separation of concerns, which is a good software engineering practice where the units that do work are quite separate from each other and have one job to do? How do I keep everything as simple as possible? So even in that description I had of the notebook, it's clear there was a lot going on and there wasn't necessarily a linear flow of the process. So how do I start thinking about that and bringing that to the code? And then how do I make things that I can then test using things like unit tests, PyTest, and other tools? How do I make sure I can test it robustly so that when I go through that route to live I mentioned, I'm quite happy putting it in production. So here on the right hand side is quite different code from where I started, right? And then what that's the first part of the journey, in a sense. What you then have to think is where is that living? What's that being hosted in? So again, in the book, I take that example and I start building an application out from it. So here you can see it's already became a lot more complex, and the code will have to change to mirror how I'm solving this problem. So here I've got a problem where I want to use that forecasting model I built to predict the amount of items in specific stores. And I've got the scenario where there's going to be an interactive dashboard someone's using that's doing supply chain planning, and they're going to want to request forecasts for specific items, specific stores. And they might also say, this model looks a bit weird, I want to retrain it, or it's up to them how often they retrain, right? It's a convoluted scenario, but it might occur. So what you start thinking is, I need to handle training requests, I need to handle forecast requests, and then I need to trigger retraining. So here I'm calling out and using something called AWS Forecast or Amazon Forecast Service for the training and hosting of the forecaster. And then I'm building these pink boxes, the handler application that really handles this traffic, routes it, and triggers the ML processing. So already you can see I've separated these out into different bits that normally in a notebook setting might all be stuck together. So in this video, I'm just going to show what that looks like again. So I've actually wrapped this into a basic Flask app. So using things like Flask RESTful and the key Flask library, which is very useful and very simple to use. And then what I've done is I've started separating out different resources for forecasting and training. I've created an endpoint for the request forecasts. And as you can see, I've just set up this to run on localhost, but you could host this anywhere and you could containerize it and deploy it anywhere. So in the resources piece for the application, I've then separated out the code I showed before and wrapped it up a bit into a more production friendly way. So I've now got different classes. So I went the object oriented way. I've got a handler for the forecast requests that takes in the key questions, starts creating the result object to then post back to the requester. I've got this forecast object that starts separating out what things I'll need it to do. So get forecast metadata, get the latest forecast, get the actual forecast. It's confusing because in the Amazon forecast, a forecaster is called a forecast. But I've embodied that separation of concerns. I've got these as separate little units that can be unit tested. And I've also kept things simple because every method in the classes does one job. So here I'm doing almost the same thing. I've mirrored that type of design, but for the training handler. So I'm now working out how I handle training requests, and then the training class is a bit more complex because there's more things to manage there. So I'm getting the latest predictor that's within tolerance. So I don't just want any predictor, but the last one that was trained that I know is within those kind of risk parameters I mentioned earlier. I need to trigger a new predictor, and for that I need to store my credentials as secrets, which is another thing that we probably don't think about in the initial stages of a machine learning project. And then I need to basically host the app, run it, and then I can start serving solutions. But as you can see, the code has changed dramatically from that initial notebook. And I think that's very important to just anticipate and embrace, really. I'll stop there, Amber. Are there any questions piling in?
We've not had any at the moment. If you've got any questions at all, pop them in the Q&A box. As I said, we'll kind of keep stopping to answer anything.
Awesome. No worries. So
yeah, I think we're all good for now.
No worries. Thanks. So those initial stages were really the kind of tester. I already mentioned about deployment. I spoke about how we wrap up the code a little bit for deployment. But how can I make that process a bit easier for myself, especially if I'm newer to this? So if I'm coming from a more data science background, how do I then become more fluent in getting things deployed? What does that look like? So what I kind of say here is that CI/CD is your friend. So if you've not heard of CI/CD, it's continuous integration, continuous deployment. And that's really a key DevOps practice. And again, I might have said DevOps now maps to MLOps in this new world. But really it's about how do you, when you make changes to your code base and pull in those changes, how do you automate bringing that into the main product? How do you automate updating the main product? all the way through to production. And so you can use different tools for this. The one I'll talk about in a second is called GitHub Actions. I think that's a really good place to start. It's very simple, it's easy to use. There was a debate on Twitter the other day if it's pure CI/CD or it's something else, but I kind of steer clear of that. I think there's other tools in the Python universe like Jenkins, which is really good. And we also have the AWS Code Pipeline, Code Build, which are fully cloud-hosted CI/CD tools. You've got TeamCity, etc., etc. So there's tons of tools. Again, it's not the tool that's important; it's the concepts and the process, right? And the key point of this process is really it's all about automating. It's all about making sure that there is no or minimal human interaction. Once you're happy with the code and you automate that as well, you automate the checks, balances, tests, quality checks to make sure that happy with the code is a kind of automated process as well. But it's all about automating the fact that once it is in a good enough place, it should then be pushed out into the world and you should update the solutions elsewhere. And the less manual process you have involved there, the better. So I remember in the early days of my career, there'd be people I would speak to who they'd write a notebook or they'd write some Python code and they had to drag and drop it into the relevant place manually. Some people still have to do that in certain organizations. This is all about cutting that out, making it automated as smooth as possible. So, another little demo video. Here I'm showing a repository that has some Airflow stuff in it, which I'll talk about Airflow a bit later. I'm just going to show you what actions look like in GitHub. So if you go into the actions tab on any GitHub repo, you'll see this. It might be empty for you if you've not set it up. Here I've set it up and been using it quite a bit. So I've got a lot of workflow runs in here of the actions working. So if I drill into that, I can then see I've got this action defined, upload DAGs to Amazon S3. And I can see from a previous run what it's doing. So it first sets up a job, configures the Git, it does some checkout behaviors, just checking the Git version information is correct. Then runs the key piece in this process, which is all about interacting with AWS. So it gets my credentials from GitHub secrets. It then runs a CLI command that copies updated code into a target. And then it runs some cleanup and checkout at the end. So this one's very simple, and you should always start simple, right? I'll talk a bit about things that you can add to this in a second. But it's a very simple example, and I've configured it so that I can then run the workflow manually. So here I've clicked the button, and this is for demo purposes. This is not how it would work normally. I'll show you that in a second. So I've now triggered that process. It's doing the upload DAGs to S3 process. So if I go in here, I'll see it's telling me it's in progress. All of those steps I just mentioned are now being triggered. And the way I've defined and told this system what these steps should be is in a YAML file. So if I go and drill down into it, I can see this AWS S3 deploy.yaml, which is stored in .github/workflows in your repository. And what you can do is there's a very simple syntax you need to follow. You define the name of the process, you tell it what it's going to trigger on. So here I've said a push to the branch main or a pull request into branch main will trigger this process, or workflow dispatch, which is that push button thing I just did. And then it'll trigger this job, which I call deploy. And then the job has several different steps in it. And it's using some actions called checkout and configure AWS credentials, which are available from GitHub Actions for you to reuse. Here I'm accessing secrets so that my access keys aren't visible in the code, but they get pulled from GitHub, so I've stored them securely. And then it runs this command, and that's the key bit, right? So it runs this copy command to copy my code to target. So here I'm just showing you what it looks like in the repository. So it sits there and it's something I can edit and change in PyCharm and keep under version control, just like any other piece of code, right? So that's like the starter for 10 for CI/CD. But what you've seen there is a quite manual demonstration. What I want to show you now is what that actually enables you to do. And again, this is the very start of it. I'm not doing anything like linting to check that the formatting and syntax I'm using is correct. I'm not running automated tests, but I should and would do all these things in a more realistic example. So here I'll show you the same process from another angle, from the target side, right? So what I'm doing is I'm going into S3, my AWS account. I am then going to see that I have several buckets, and the bucket I'm interested in is this GitHub Actions one. So I go into that, and you'll see there's lots of Python files from that repository already in it. And the key one I'm going to look at is this classification pipeline DAG. So this is an Airflow DAG. And again, I'll talk about Airflow later. But this is something I'm going to use to orchestrate machine learning workflows using Amazon's managed workflow instance. So I look at the file and I can see in the first 4 lines, I've got 4 lines of imports, right, from Airflow and from basic Python packages. You can see I've done this a few times with all the versions of the files. So what I'm going to do is I'm going to go into the repo with the configured YAML I showed you earlier with the action set up, and I'm just going to make a change. So here I'm making a change. I know it's hard to see in the dark, but it's making a change to show basic CI/CD. I'm just putting that in as a comment. So I've now got 5 lines at the top of that file. But you would normally be updating the DAG or whatever you need to do. I then commit the file, and then I push. So I write my commit message, making a change in code and showing CI/CD working, hopefully. And then I commit and push into main. Okay. So I've made a minimal change. I'm happy with it. I'm pushing to main. I'd normally not push to main. I'd push to dev, but that's a different story. And you can see I've pushed the commit to GitHub. Okay. So I've just pushed to GitHub. I've not done anything with AWS. I've only just pushed to GitHub. I've went through my normal development process. If I go back to the bucket, you can see there that file was last updated at 2028. And then when I've ran this, it's 2040. So what's happened is in real time that's been updated. So if I open the file on AWS, I can see that I've got that 5th line in there, that comment, right? So that's a bit of a simple Mickey Mouse example, if you like, but it's really quite powerful because that Python code there and in that repository is actually what is then feeding an Airflow instance hosted on AWS. So it reads in that DAG and uses that to orchestrate a series of machine learning jobs. So what I've done there is I've updated the orchestration layer using CI/CD, or really in this case CD, because I didn't do any integration checks, I didn't do testing, etc., like you mentioned. So that's to me a simple way to get started on that making deployment easier journey, that sort of CI/CD piece. Oh, don't watch again. Last piece on deployment is I'm a huge fan of using tools for helping you do configuration and configuration as codes. So I love YAML. So I think YAML and configuration tools are really, really helpful for defining pipelines that can be used across multiple different use cases and different applications. So here, for example, I'm using a tool that I quite like, Facebook's open source Hydra solution, Hydra package. So framework, sorry. So it's a framework for managing hierarchical YAML, essentially for really complex configuration files. And what it helps you do is in your Python code reference, again, these really complex configurations in a way that allows you to write backbone codes that could do really quite different things based on the configuration. So for example, you might write a kind of generic machine learning pipeline that runs some type of model, linear regression, deep learning, whatever. And it could be that for a few different applications, all you actually need to change is maybe the data it's pointing to, and maybe some other configuration file that tells you the feature names, for example, that you want to pull in. You could use Hydra then to build a quite clean piece of Python code that would read in the YAML, the different YAML in each case, but all of the other codes the same, and it would do quite different things. So what that enables you to do then is abstract away some things from your core code and make it a lot easier to maintain and manage. So if I were to change the data it's pointing to in that example, I just update a line in the YAML and I can update it with that CI/CD process I mentioned earlier. And that means I haven't had to recode and refactor a lot of my core code and redeploy that up. So basically I've made things a lot easier to maintain. I can move faster. I can also do things a bit more safely because I know the core code's been tested to the hilt. I know I just need to make sure that configuration change is okay. And that I think is really powerful. I'll stop there. Any questions, Amber?
We do, yeah, we have 2. So we have one question, which I think was just missed from the Q&A before, which was where can we find the code and video?
Awesome. So we'll maybe send that out in the email, or I'll kind of give it to Amber. But if you go on GitHub and look for machine learning engineering with Python, that will give you the main repository from the book, and that's also linked to in the book. The repo I just showed you there is actually on my GitHub account. So it's Andy McMahon629. I'll flash that up at the end, is my my GitHub sort of handle. So if you search that, that's there and it's public. So it's MLEIP Airflow. The MLEIP is because originally the book was called Machine Learning Engineering in Python, not with, but everything's on GitHub. So we'll try and share some links out, or I'll even post it on LinkedIn as well if we can't do that. Yep. I'll put the videos on YouTube as well, I think. And you'll also probably see a recording of this available later.
Indeed.
So, yes.
And we also had another question, which was, can you please explain DAGs a little bit more?
Oh, good, right. I'm going to talk a bit about this later, but I'll just give a brief thing a little bit. So DAGs is directed acyclic graph, which is just a fancy way of saying a series of steps that can be a bit of sort of spaghetti, but they basically define a logical flow for some sort of operation or workflow. So DAGs are used under the hood in Spark, in the Spark engine, Apache Spark, for working out the different steps you want to do in your queries that you're running in Spark or PySpark, etc. But they're also used in this open source tool called Airflow, which I'll come on to later. So that is essentially an open source orchestration tool, and the DAG defines the different processes you want to run. So in the example I'll give later, we maybe run a training scenario, and then I run an inference scenario, and then I save the model. That can be defined in a DAG, and then that's run and executed by Airflow. So that's roughly what a DAG is, my sort of off-the-cuff explanation. That's good. It's a good question. Any more?
We've just had another one come in saying, what's the difference between an ML pipeline and a CI/CD pipeline?
Okay. So an ML pipeline, and I've actually got a little section of pipelines later as well, but a pipeline fundamentally is just a logical linear process, different from a DAG, right? So a DAG is a way of defining pipelines, if you like, or executing pipelines. A pipeline to me is just a linear process where the result of one step feeds into the next. So an ML pipeline is really one where it takes data, does what it has to do to the data to feed into a model, feeds into a model, and either trains the model or runs inference on the model and spits it out. A CI/CD pipeline, and I maybe used that word erroneously, but to me that's really about defining those steps I mentioned before. So in that YAML it said first step, check out the code, second step, get credentials, third step, run a copy of all the Python code up to AWS. That's a sort of pipeline. So to me, that's a CI/CD pipeline. It's really about the process of the continuous integration, continuous deployment. And that's completely separate, right? I don't need to write ML code to do CI/CD. I just need to write Python or any language actually, and you could do CI/CD. So it's a bit different.
And we have just had another one come in as well, just asking, is this session going to cover AWS SageMaker pipelines as well? Oh,
no. That's a brilliant question though. The bit I'll mention at the end about the work NatWest did with AWS, the blog posts I'll link you to have tons of stuff on SageMaker pipelines. Like that is my go-to reference for SageMaker pipelines now. So I'll talk about that at the end, but I won't go into detail here because I'm trying to be tool agnostic. I'm probably failing, but I'll try a little bit. So really good question. The little bit at the end about NatWest and AWS is MLOps platform. That will cover information you can go to for SageMaker pipelines. Really good question. One of my favorite tools. I think I'll crack on and then we'll look back in, but those are really good questions, guys. Thanks for that. So now we're going to get stuck into a bit more on the kind of ML-y bit of MLOps. So model management, right? So how am I looking after the machine learning model? That piece I mentioned earlier needs fed and watered and looked after quite a bit more than normal software. And for me, there's two different practices within model management. So in this sort of slice of a typical project, we do the play step, the prototyping step, the developing, the solution, and then the deploying. There's two different practices within that embody model management for me. The first one is tracking. So that's where you're doing experiments. So some of the notebook stuff I showed you earlier, or you're running hyperparameter optimization, you're trying lots of different parameters and seeing which one gives you the best performance on your problem. And you just want to track all that and log all the metrics, log all the parameters that you've run, what are the results. So essentially like a lab book, you're writing in your lab book, that's what model tracking is for me, experiment tracking. As you get to the later stages of your project, you then have behaviors that are more what I would call model registry behaviors. So this is where you take the models that you're happy with and you tag them appropriately. So you basically say this one's production ready, or this one's still in staging because I want it to move to production, or this one's just a development model. And it's basically a way of creating a library. So if before I was talking about a logbook, you're now talking about a library of your models and the state of them, and just basically how happy you are for them to be the ones that move to production. And that's important because in production, what you'll be able to do, or what you should do, so that you decouple where your model lives and where your code lives. When you're running your code, you should be able to go into the model registry, that library, and ask to take out a model. So you should be able to go into model registry and say, what's the latest version of the classifier for finding XYZ? I want the latest version of it that's within tolerance in terms of metrics. You should be able to query the solution that does your model registry, pull out that model, host it, and then run it in that ML pipeline you've got in production. And doing this in code is super easy. So the examples I've got here are using MLflow, which is a really popular open source one. As I mentioned before, it's not about the right tool. There's tons of tools that do this, either do the tracking or the model registry, or often both. MLflow does both. So in the book in here, I'm just showing a little snippet, and I'll show you a little demo video, but it's very easy. That's about 20 lines of Python. And in that, I've started an MLflow experiment. I've logged the parameters for a model that I've then trained and ran predictions on. I've then also logged the model in the model registry with some basic information. And then I can also work with that model registry in a bit more of a complex way. So here I'm showing that, and again, just 10 lines of Python or similar, I am able to go to that model registry and change the stage of the model because I'm particularly happy with its performance. And I changed that stage automatically in, again, another pipeline. So I've maybe ran through and said, right, I am more than 80% accurate. I therefore want to track that as a staging model for the last bit of evaluation before I ship to production. Or it's passed every test I've got, I'm then going to switch and make the stage production so that that process I mentioned earlier can grab the right model. And in a little demo video again, just seeing what this looks like. And this is from the book repo. So when I link out to this is in chapter 3. Here I've got a little bash script that just fires up an MLflow server locally, which is just, it's very basic defaults. You can play around with lots of options here about pointing to different data stores for storing the model artifacts, different hosting options, etc. It's basically a very simple command to spin up the server. So here I am in my Linux terminal. I'm just going to run that, and then I'm going to open the server. So it's just running localhost here. So open that up, and you can see that just by installing MLflow, it's just pip install MLflow to get this package. It actually already provides you with a kind of nice UI front end, so that when you store your models, and there's one-liner example there. I think I zoom in a minute. I hope I do. Yep, you can see that there's information about a previous run I've done. So just using that syntax I showed earlier, which I'll now dive into a bit here. So in my code, I've told MLflow on line 18, after I've imported all this stuff, set tracking URI just says, where am I looking for this server, this service where I'm going to write all the results. I load a basic data set. Here it's the wine data set from sklearn. I split into train test. I then start an MLflow run with your run name as the run name, very original. And then I define some parameters. I train a basic classifier here. So I've scaled the features using standard scaler. I've then trained a ridge classifier, and I've done some prediction on it. I then log the metrics. So sklearn just lets me do different metric reports. So I've got accuracy, precision, F1, and recall. I then log the parameters to MLflow, and I log the model as well. What I'm going to do now in the video is just quickly run that process. Or actually I'm not. What I remember to do first is a deep dive into what's in this, mind blank there. So if I go in here to what's already been stored, I can see that it's not just that metadata you get, you also get little snippets of code of how to log in the model. Pull in the model to your processes that I mentioned earlier. And you can see that it comes with different definitions of how to create the environment or pull in the model. So it's got the model pickle there. It's got a conda YAML for creating the environment. It's also got what's called an ML flow model, where you can take environment and artifact all together. But here again in the terminal, I'm just going to do that basic Python process, run that piece of code that I just showed you. It takes a wee second. And then you can see it's done some stuff and it's spat out some JSON, right? So the key bit here is that it says it's created version 2 of the model. So it's already aware there's a previous version of the model in the code, and then now we're on version 2, and it's allowed me to stage it, tag it with the appropriate labels. So is it staging, is it archive, is it none, etc., for example. And here you can see it's logged the second experiment I've ran. So it's logged the fact that I've actually run this again. All the numbers are the same, just because it's a demo. But again, I've got all that information about how to pull in the model, how to run it, where the model artifact is stored. And then interestingly here, I can see in the model registry piece of MLflow that I have 2 versions of the model. So I'm now on to version 2. And this is this model registry behavior I mentioned and why it's important. So I've got 2 versions of the model. One is staged as archived. So I know if I query MLflow programmatically, I don't want the archived models. The other one's labeled as none, but I could label that as production or development, etc. And that just means I've got some control over what I get back when I go into MLflow programmatically, which I can do. And in any good model management solution, that's what it'll let you do as well. Cool. I'll run through this one, then I'll stop again for questions, I think, just to keep plowing on. Don't worry, everybody. I hope you're still with us. We've not got too many left. So the second bit that I really think is so intertwined with machine learning is performance monitoring. So I mentioned earlier how monitoring is a bit different for machine learning versus traditional software. So to me, it's really about defining the process so clearly for this one. I've mentioned that a lot before, but for performance monitoring, it's particularly important because you need to think, what is your metric for performance? How frequently are you going to look into it? What's the actions you're going to take in the back of it? And how much can you automate of all this? So normally you talk about drift, and there's 2 types of drift typically. So there's concept drift. So that's where your features change their relationship relative to each other and maybe to the label you're going after, the prediction target for your model. And then there's fundamental data drift. So that's just when the world changes, if you like, so the distribution of things change. So an example of concept or covariate drift, completely off my head, is when the 2 features you're using to predict delivery times slightly change. So it turns out that actually before they'd sort of added together to produce a rough number, now they multiply, something like that. And data drift is maybe something more fundamental. So the demographics of the data you're seeing change. Before you were looking at adults from age 25 to 34, you're now looking at 34 to 45. So that's quite different. That might lead to quite different levels of performance of the model. And the aim fundamentally is to detect this change in performance as early as possible once you define what performance means. And then often you want to retrain the model, or you want to take some other action based on your operating model for your solution. So you should always think what the operating model is for when the performance degrades or changes at least. So if I detect data drift, it might not necessarily mean a performance change in the model, but it might be something I want to investigate. Same for concept drift. And then fundamentally, if the model performance is degrading, what action do I want to take? Do I want to get a data scientist to look at it and decide if we retrain? Do I want to automatically retrain? Do I want to raise an incident that causes the system to go down, etc.? So there's a lot to think about there, I think, in terms of MLOps and how it fits into the wider picture. The good news is doing this in code is super simple again. So here I've shown an example from the book where I use a package called Alibi Detect from Selden. So Selden's a good set of tools, or a platform really for doing machine learning modeling, and model monitoring, and MLOps generally. Here I've shown the open source Alibi Detect package, and what that helps you do is just do some very quick detections of drift. So again, not many lines of Python. What I've done here is initialize a detector that'll detect drift on my data set, so data drift. I've given it a p-value to say what my statistical threshold is. I've then given it a reference data set, and then 2 lines later, I've got preds equals detector.predict on new data, and I've asked that predictor, is there drift here? And then if it returns yes, I could do one process. If it returns no, I could do another process. So I could retrain, or I could raise an incident in my IT management system, etc. And that's basically performance monitoring, at least the start of it in a nutshell. Any questions, Amber?
I've not got any at the moment. I think we're all good to carry on.
Excellent. Hoping you're not all asleep. I'll assume not and crack on. So not many sections left in this crash course. So we mentioned earlier about pipelines. I'm just going to do a brief overview of why pipelines are important to me. So this is a bit more advanced stuff, I think, not in terms of the actual Python code, but in terms of the concepts and their importance in my view. So I always talk about this with stakeholders, with people I build solutions with, and with my team. So they're probably really sick of me saying this, but for me, machine learning systems are basically a composition of lots of pipelines. And as soon as you start thinking about that, you'll then start thinking, what are the pipelines made of? What components and what processes? So here, for example, you might have a system that's got a training pipeline, an inference pipeline, and then a monitoring pipeline, using a lot of the tools and techniques I've already mentioned, right? The training pipeline is going to take some scored data with clear labels. It's going to engineer the features to make it ready for modeling. It's going to train a model and output that model somewhere. The inference pipeline will take new data via an API call, via a new data set being updated, etc. Feature engineer it in the same way, and then run the model and surface the inference results somewhere. And then in monitoring, you're going to look at the results of those processes, you're going to run some analysis, and then you're going to alert in some way, like we just mentioned. All of that can be articulated, it can be defined in terms of pipelines, and that helps you organize your code better, organize that Python code better, helps you modularize and think, what's that separation of concerns again? So my training pipeline, I could see here I've got at least 3 major steps, and then I start breaking it down more. I've got fundamental steps within that. And then I can start building code that's more amenable to unit testing, has separation of concerns, is kept simple, is more maintainable, etc. So that's a high level view of pipelines, but to me, that's what ML pipelines and MLOps pipelines represent, is really these steps that are important for creating the models, running inference with the models, and then alerting when the models need some looking after, basically. So some tools, I know I mentioned being tool agnostic a few times, but some tools I'm playing with just now that I quite like in my spare time when I get some is Kubeflow and ZenML. So Kubeflow is the machine learning toolkit for Kubernetes. So it's based on Kubernetes, which is how you manage multiple containers in a very scalable and platform independent way. The idea here is, how do you then build machine learning pipelines on top of that so that you get the same portability, scalability, and ability to run on different platforms. So I really like it. I think it's got good API that's quite simple to use. I think it's very clear, the documentation is very good. So I quite like Kubeflow. Also started playing with ZenML, which is an open source MLOps framework. And what I love about ZenML is that it's super simple abstraction for your pipeline steps. So these pipeline steps I just mentioned, it's so clear how to map that to code in ZenML. It's basically like do X, add a stage, do X, add a stage. And from that, you can just gradually build up quite complex pipelines, but they're very readable, they're very clear, they're very modular. And I think that's really good. Also really like their idea of write local, run anywhere. So you can develop on your local machine, but it's built with the idea that it will hook into so many different solutions. Last one, I think, second last one, roughly, and then we'll stop for some final round of questions. Orchestration. So this is onto the DAGs we mentioned earlier. You've built all these pipelines, you've done CI/CD, you've unit tested to death. How are you then going to trigger these things to run? And that's what orchestration is about. How are you going to tell the system to run the machine learning code or update the model when it's not triggered by, say, an API call? So it's not triggered by somebody coming to you, a client, and saying, give me the answer, like in the earlier application example. Something you might be running on a schedule, or you're running on the basis of some other type of event. And when you get to this stage, I would really recommend a tool like Apache Airflow or something else that does the same job. And there are lots, there's a few out there. But this is really good because it's got a very simple API, very simple Python syntax. It's open source, and it does have managed versions as well. So on AWS, there are managed workflows with Apache Airflow, which I reference and use quite a lot in the book. And that's good at kind of abstracting away some of the boilerplate you'd need to manage and own, and giving that over to AWS to look after. The question earlier about DAGs, on the right hand side is that DAG actually that was showing in the example earlier. So what you do in Airflow using this simple Python syntax I mentioned is you define a DAG very easily. So DAG equals DAG, and then you define some information about it, the name of the DAG, any default arguments it's got, schedule interval. So you can tell Airflow how often you want it to run. So do you want to run every 1 day, like I've said here, or do you want to run more frequently? Or do you want to trigger based on an event from a Kafka topic or something? You then define the different stages that will be part of your DAG. So part of this graph, this series of steps. So step 1, get data. Here I'm using bash operator from Airflow. So that's assuming I'm on a Linux or Unix system, and it's got a Python environment there. So I'm assuming there's a Python environment where I can run Python 3, this file, and that'll get my data. That's already been built to get data. I've then got train model step, similar idea, but now I'm running something that trains the model. I then persist the model. So I run an operation that says, right, whatever model I trained, persist to MLflow with the right metadata, the right processes I mentioned earlier. And then the actual definition of the DAG is this little orange bit at the bottom. So it's really when I start saying this step follows this step, follows this step, and that's the process I want to execute on the schedule I've defined. So within, again, just a few lines of Python code, I've created something that could be triggering supremely complex processes, but the actual orchestration piece is very simple. So get data, train model, persist model, any other processes you want to trigger. Could be really, really complicated, but the actual orchestration layer is quite simple here. The other cool thing about Airflow is it's tons of hooks to different solutions. So someone mentioned SageMaker earlier. There's hooks to SageMaker directly from Airflow. There's hooks into Kafka. There's hooks into so many different tools that just lets you build these really complex pipelines and complex solutions quite quickly, which I really like. And the final bit of the crash course, I'll stop again for questions, is you need to bring all this together in some sort of process, some sort of overarching mental model, I think. So in the book, I talk about what I call the model factory. So this is once you're able to connect your training system for building models, where you store the models, where you run the predictions on the back of the models, where you detect the drift in performance. And once you hook them all together, there's nothing to stop you continually pumping out models that you can then submit into production if you're happy with that process. And I call that the model factory. It can kind of run itself and just keep creating models. And then within that, how are you running your inference? You sometimes think about different ways of doing it. So here I talk about what I call train persist. So you train the model and then persist it to a model store and then go away and train another model. Or you can do train run. So if you had an unsupervised model where you don't want to store a model artifact, you just want to run there and then after you do some clustering or something, you could do train run and just run it and not store it anywhere. But that's roughly how you'd bring it all together. Just realized that says 202 and it should be 203. Anyway, any questions, Amber, before I do the last few minutes?
Yeah, we've just had one come in, which is how do you ensure that the data quality before moving to data pre-processing? So for example, in the case of object detection, how many annotations are present per class or whether the bounding box is precise or not. Are there any tools which can ensure data quality? I think this is the most important thing for industrial use cases.
Oh, that's quite a good question. The example you mentioned, bounding boxes, etc., sounds specific to me, but I'll talk about some things I've used in teams before. So you could use the alibi detect stuff for quite tabular data, does unstructured data as well for kind of data quality checking. That's quite good things. Another one is Amazon's or AWS's DQ package. So they have different flavors of that. So it's based on Spark, but it's useful for doing things like basic checks on how many nulls have you got in certain columns of data, or all the features present, what's the classes that you have. So if there's some sort of list of types of products, you can check that the list of types of products not changing too much with time. You could do anomaly detection in all these. It also has a Python version, a Python wrapper called PyDQ, which is quite easy to use and is very useful. And And I think that that's kind of the standard ones I go to. I think sometimes you should be willing and able as well to go really into what kind of data quality challenges do you think you have that might not be in an off-the-shelf tool. So it could be the specific example you mentioned. You need to build a little script that can do it. And I think the key thing is just going back to that pipeline question, where in the pipelines do you want it to run to make sure that you catch it early enough, and what's the process that feeds into. But those are kind of two tools that come to mind, I think, alibi detect and DQ.
Oh, okay. Do we have any other questions? If you've got a question, drop it in the box now.
Awesome. Right. I'll just finish off this last wee bit. This will be super quick, I think, because I realise we're at time. So I've given a lot of information there. I'm not expecting you to digest that and tomorrow we'll be able to do it all, right? And it's very much starter for 10 stuff. So there's a lot to build on top of that. But where could you eventually get to with this? And this is where I've got my NatWest hat on now. So this is all stuff that's in the public domain, but as part of a collaboration that NatWest did with AWS, we built an MLOps platform that is scalable across what we believe is the entire enterprise. So on the AWS machine learning blog, which is no mean feat getting on that blog, I have to tell you. There's a lot of rounds of edits for that. There is a 4-part series explaining how we did this. We've got no secret sauce in there. It's all based in Amazon best practice. It's all based on the best tooling, and it's based on stuff that the bank are very happy to share. But I'd really recommend reading these blog posts to see how you would build an end-to-end platform that works using things like SageMaker and its surrounding ecosystem. So that's kind of the introductory one. Later in the series, we go into a lot more detail. So here I've got the architecture. I won't go through this. We definitely don't have time, and it's very complicated. But roughly, the key points to draw out are all the things I mentioned before about modularity, scalability, automated checking, etc., automated provisioning, automation. That can scale up to the whole platform level as well. So here we've been able to use tools like AWS Service Catalog to automatically provision data science environments, those dev, pre-prod, prod environments I mentioned earlier. All of the tools you need, so SageMaker, SageMaker Studio, all the different infrastructure you need, all of that's automatically created upon request from someone in the bank, from a data scientist. And then we have CI/CD built in, like I mentioned earlier, to everything. So it doesn't just work on our SageMaker templates, SageMaker pipelines. It also works on our infrastructure as code and how we're building the entire environment, the entire platform. So all of the things I mentioned don't just apply to your basic Python code, they can apply to all of the bits of an entire MLOps platform as well. And that's what makes it inherently scalable. It's that automation piece. And I mentioned before about pipelines. This is a bit of pipelining that I'm particularly proud of. So in this platform, when you request, we talk about this in the blog post, when you request a new environment to do your ML stuff, you get pre-populated templates with a lot of those pipeline steps I mentioned earlier. So you get kind of a starter for 10 that's really quite complex and does a lot of stuff for you. So pre-process your data, check the data quality, check it for bias. It could train your model in this case for the training one, evaluate the model, store the results, create the model, do some integration testing, post-process the results, do checks on explainability, bias, and quality of the actual model. And then at the end, push the model into model registry for pickup later in inference. So someone mentioned earlier about SageMaker. This blog goes into detail about how you can use SageMaker in a kind of supercharged way across all of your projects. It's really cool. And that's it. So I'm just going to quickly wrap up with saying I did not cover a lot of stuff. I won't go through everything I didn't cover because it's pretty infinite. But there's just tons of stuff out there. I would really recommend looking at different resources like AWS Well Architected. Stuff on their website is really good. Give that a Google. There's other books out there introducing MLOps, machine learning design patterns from O'Reilly, engineering MLOps from Pact, which complements my book quite nicely. That focuses on Azure a lot. Mine's is on AWS. There's just so much out there. So no matter where you're starting from, you're always going to be in a journey. You're always going to have so much more to do and to learn, and I count myself in that as well. And hopefully we've recognized through this presentation that MLOps is not magic. Getting started is not too difficult. I don't think anything I've said was too advanced in talk. If you're doing any ML, any data science, I think you need some sort of MLOps. Some of the practices I've mentioned in there. MLOps is not the same as the tools you choose. And once you do it and start doing it, you can do it all the way up to the enterprise scale, which I think is really powerful. And then if you want to reach out to me, here's some places you can do so. And with that, I'll thank you so much for listening.
So if anyone's got any questions, any final questions, as I said, drop them in the Q&A box now. But yeah, no, thank you, Andy, for joining and for kind of hosting tonight's webinar. I'm sure it's been obviously a great help to people looking to kind of make that introduction to MLOps, kind of finding the feet with it. As Andy said, if anyone has any follow-up questions or wants to reach out, please feel free to reach out to Andy or myself. We do record these webinars, so a recording will be posted across our LinkedIn and also on our YouTube page, where you can also find other episodes of the live series as well. So as I said, Andy's book, we've kind of been given a discount code, so we'll be sending that out hopefully tomorrow across on email, so keep an eye out for that. And we'll also reach out to announce some winners of the giveaway. And I think that's pretty much everything. It doesn't look like we've had any further questions, just some thanks to Andy. So yeah, thanks Andy once again. Apologies again everyone for the slight delay. But yeah, really appreciate your joining us, and we'll see you next time.
Thanks all.
Okay. Thanks. Bye.